Hello everyone. Put on this example. It's an inclined plane with angle theta. It's a rough incline, and this surface is also rough. A block of mass m is released from height h. This is h. And ultimately it is found over here at a distance of s. So you release it from this point and finally it is found over here. Coefficient of friction everywhere is mu. Mu, mu. Question is, find out mu. Write down the question. An object is released. An object is released on a rough incline from height h. And is finally found at rest. And is finally found at rest after moving a distance s as shown in the figure. Find out coefficient of friction for the rough surface. Remember, for both incline and the horizontal part, your coefficient of friction is mu, and mu is what? Same. And it is given that mu is less than tan theta. Now, who will tell me why we have given this information? This is given that coefficient of friction, whatever it is less than tan theta. If you know the answer that why should we provide this information, then write down why it should be provided. Write down the reason in the comment box. If you cannot, simply find out mu, and I will tell you later. बहुत सही. That's what the answer is. If mu is tan theta or greater than tan theta, just remember what is mu, what is tan theta. If you remember tan theta, theta was the critical angle. So when you raise the angle of the incline, there is a particular angle when block starts sliding down, and that was what? Tan theta equals to mu, angle of repose, the critical angle. So if you make this surface very rough, if mu is very high, then this block will not move at all. Just so that it can move, we are saying that mu is not very much. It's less than the critical value. So the moment you release it, it will come down, it will slide down, and ultimately comes to rest over here. That's why we have given this mu less than tan theta. In case somebody wants to note down the reason, we can write the statement. If mu is greater than or equal to tan theta, then inclined surface will be too rough for block to move. If mu is greater than or equal to tan theta, then the inclined surface will be too rough for the block to move. Now, there is one way of answering this question. If somebody is interested, you can try that with the help of laws of motion. You know the force which is acting on the block, mg sine theta, and since it is coming down, you know that friction is also acting on it. So the downward force is mg sine theta, and the friction which is going to act the moment you release it, it starts sliding down. And whenever things slide, you know that friction becomes what? Maximum. What is the maximum value of friction? Mu n. What is n for an inclined surface? Mg cos theta. Complete logic. The moment you release it, it starts sliding down. It's moving. If it is moving, either use kinetic, or if they are giving you one mu, use that as mu n. These are the two forces acting on the block. It starts with zero velocity. Find out this length, h is given, you can find it. Find out its velocity over here. And then when it is on the horizontal surface, somewhere over here, it will finally come to rest at this point. V becomes zero over here. So when it is over here somewhere, friction will be acting in this direction. This friction is also maximum because block is moving. It will come to rest over here. It's moving and therefore friction is maximum. What is maximum of friction? Again mu n. But this time we are on the horizontal surface and therefore n is what? Mg. On the inclined, normal reaction is what? Mg cos theta. On the horizontal surface, normal reaction is what? Mg. It starts sliding down and then it moves in this direction. This friction is going to oppose and finally it comes to rest. You have the equations like v square equals to u square plus 2as. With the help of laws of motion you can find it. But I want you to answer this question with the help of work and energy. Concept of work, concept of energy should be used to answer this question. Let's see how many of you can do that. So far, not a single response. Let's answer the question again step by step. Can we use COME? Yes or no? Can we use COME in this question? Can we conserve mechanical energy in this question? And I hope you are writing no because friction is present. We cannot use COME. We cannot use it. And the moment you say we cannot use COME because friction is acting, friction is what? Non-conservative. It will take away some part of energy. So what is that which we use? How many of you remember the step? Once we say that we cannot use COME, and what is that which we use? I asked the same question in the previous lecture also. Write down fast in the comment box. If I cannot use COME, then what is the approach left? And make a habit of remembering all these steps. That's how you attempt questions. And I hope you are again writing this. W external is what? W external is change in kinetic energy, K final minus K initial. K for kinetic energy plus U final minus U initial. U is potential energy, which is gravitational potential energy in this case. So this is your initial point. This is your final point. Initial, final. K final, 0. 0. K initial, 0. It started with U0, finally comes at rest, V is also 0. What is U? Gravitational potential energy. जहां आपकी मर्जी हो वहां आप उसे क्या लेते हैं? 0. ज्यादा अच्छा कहां रहेगा 0 लेना? ग्राउंड पर. तो हमने बोला यार यहां ले लो 0. ग्राउंड लेवल पर 0 अगर लोगे मतलब फाइनल पॉइंट पर आपने क्या लिया हुआ है? 0. अगर आपने फाइनल पॉइंट पर 0 लिया हुआ है ग्राउंड लेवल पर, तो h हाइट पर क्या होगी एनर्जी? mgh. दिस इज h. ग्राउंड पर कितनी है? 0. फाइनली इनिशियल h हाइट पर क्या है? mgh. This is the right side. The only thing left is what? Left side. I'm giving you 30 seconds more. Find out the left hand side and question is done. Let's see if you can answer this. You just need to find work done by external force. Now, what is the external force? External force is friction. How many forces are acting? How many forces are acting on the block? Gravity, normal reaction, and friction. Force of gravity, force of normal reaction, and force of friction. These are the three forces which are acting on the block. For force of gravity, we are using potential energy. And just because of this, अब आप इसका वर्क काउंट नहीं करोगे. नॉर्मल रिएक्शन, इसका वर्क जीरो है. नॉर्मल रिएक्शन इज एन एक्सटर्नल फोर्स, लेकिन इसका वर्क जीरो है. क्यों? जब आप यहां पर हैं, नॉर्मल रिएक्शन और डिस्प्लेसमेंट के बीच का एंगल कितना है? 90. इसलिए उसका वर्क जीरो है. जब आप यहां पर हैं इंक्लाइन पर, तब भी नॉर्मल रिएक्शन इस तरफ है, डिस्प्लेसमेंट इस तरफ है. दोनों के बीच का एंगल कितना है? 90. एंड देयरफॉर ये जो पार्ट है, दिस इज गिविंग अस WFR. तो वर्क डन बाय एक्सटर्नल इज व्हाट? WFR. ये डिसाइड करने का तरीका है, इसको याद रखना. कितने फोर्सेस हैं, क्या क्या उनका रोल है. So you just need to find work done by friction, and you have the force of friction over here and force of friction over here. अब बचा क्या? केवल इनका वर्क फाइंड करना. देखना, मैं इस तरफ कैलकुलेट कर रहा हूं, आप जहां भी आपकी मर्जी हो वहां करना. WFR. So WFR for this part, for the inclined part. Suppose inclined part, its length is L. We can find it with the help of H. पता है वैसे आपको कितना है L. This is L, suppose. How do you find work? Force. कितना force है? Mu mg cos theta. This multiplied by displacement into cos of 180. L नीचे आ रहा है, फ्रिक्शन ऊपर लग रहा है. Work done by friction on this part. Let's find out work done by friction on this part. कितना फोर्स है? mu mg. This side. बॉडी का मूव कर रही है, this side. Displacement S, what is the angle? 180. Done. What is L? You have a right angle triangle. This is H, this is L, this is theta. Calculate कर लेना. This is coming H upon sin theta. This is H. This is L. What is H upon L? Sin theta. What is L? H upon sin theta. Put the value of L over here. Simplify. And you will get what? Mu. Mg, Mg, Mg gone. Negative sign is gone. Cos 180 is what? -1. Cos 180 is what? -1. So this side you have got H only. Minus mg is gone. Cos 180. Simplify करते रहना भाई. This side, this is mu cos theta L H upon sin theta plus mu mg into this. Mg is gone. हो गया यार, शिफ्टिंग कर लेना, आंसर आ जाएगा. If you understand this, write down yes in the comment box. If you have any confusion, Tell me what your confusion is. प्लस पूरी कहानी याद रखो किस तरह से क्वेश्चंस को अटेम्प्ट करते हैं हम लोग. You're asking FR part. What do you want? You want me to explain force of friction or work done by force of friction? Tell me this. What do you want me to explain? Work done by friction. जब ये ब्लॉक यहां से यहां आएगा, इसका डिस्प्लेसमेंट कितना है? L. What is the direction of displacement? Downwards. What is the direction of friction? Up the incline. And what is work? Force into displacement into cos of angle between force and displacement. Force of friction, displacement, cos of angle between force and displacement. We cannot find work done by friction from this position to this position directly, because when we use force dot displacement, force must be uniform. Force of friction is not uniform. Over here it has a different value, and over here it has another value. So we are finding work in two parts. For this, friction is this direction, displacement, the angle is what? Cos 180. अब यहां पर हो, फ्रिक्शन का डिस्प्लेसमेंट के साथ क्या एंगल बना हुआ है? 180. Those of you who have seen the lecture I sent on Sunday, write down yes in the comment box. One of you is asking why we did not include work done by gravity. So I told you this thing before also. For gravity, if you calculate its work, if you use its work, then we cannot use potential energy function mgh. If you do not want to use mgh, then you can take gravity as an external force, then friction and gravity both are the forces, all the forces kind of, Then on the right side, it will be change in kinetic energy. Very first statement, work done by all the forces is what? Change in kinetic energy. But since work done by gravity, we change its side, it becomes negative of work done by gravity. Remember, negative of work done by internal force, which is given a new name, that is change in potential energy. So I explained this thing, that if somebody is using work done by gravity, then he cannot use its potential energy function. If you want to use potential energy, then don't use the work. You cannot use both at the same time. क्या प्रॉब्लम आएगा? Let me tell you the problem. प्रॉब्लम कुछ इस तरह का आएगा कि मैंने आपको 20 रुपीज दिए, तो फिर आपके पास कितना पैसा मिलेगा? 20. अब आप ये आर्ग्यूमेंट नहीं दे सकते कि सर ने 20 रुपीज दिए, मेरे पास 20 हैं. अच्छा, सर से मैंने 20 रुपीज लिए, बात सेम ही है. इसका मतलब 20 और है मेरे पास, and you've got 40 rupees. No, it's only 20. Again, I gave you 20 rupees. So if somebody says that work done by gravity is 20, and you say that I have taken 20 rupees from the system, then you cannot use this 20 twice. Either use work done by gravity or use its potential energy function. For further detail, watch first few lectures on work energy and you will understand everything, because I have explained this part many times before also. Write down power. We have seen work, we have seen energy. Let's give it some power. What is power? Let's write down the formal statement first. Rate of doing work is called power. Rate of doing work is called power. Let me ask you first, what is power? A scalar quantity or a vector quantity? Write down in the comment box. Just taking an idea. Power is a scalar quantity or is it a vector quantity? Good. It is a scalar quantity. Write down the statement and then we'll see why it's a scalar. Power is a scalar quantity and its unit is joules per second. Why? We'll see that. Or watts. They both are same. Joules per second or watts. There's one special unit which they also ask a question on, which is called HP. Let me see how many of you know what HP is with the help of this relation. If you can fill in the blank, what should come here? If you can write the number, then it will tell me whether you understand HP or not. At the same time, it will give me an idea whether you understand what this relation is. 1 HP is watts. It's a GK type question basically. Good. This HP is horsepower, and 1 horsepower, remember, is 746 watts. You can expect an objective question like this. Joules per second, which is nothing but watts. 1 horsepower is 746 watts. Now let's see why power is a scalar quantity and why it has a unit like joules per second. The way power is defined is what? Rate of doing work. And how do you define rate? Rate is defined with the help of dW by dt. Rate of change of displacement, ds by dt. Rate of change of velocity, dv by dt. Rate of doing work, dw by dt. This tells us why the unit is joules per second. Joules second. Now, it also tells us why power is a scalar quantity. What is work? Scalar. What is time? Another scalar. So it tells you both why power is scalar and has a unit like joules per second. But now, let's open this. What is dW? And I hope you remember dW is not F dot S. dW is F dot ds. W is F dot S. What is dW? F dot ds divided by dt. This takes this shape. And in this shape, look at this part now. ये आपको समझाने के लिए मैं इस तरह से हाईलाइट कर रहा हूं, आप भी कर सकते हो. Now looking at this number ds by dt, अभी थोड़ी देर पहले मैंने बोला, what is rate of change of displacement? V. Therefore, P is F dot V. ds upon dt is what? V. How do you open dot product? Magnitude of first vector, magnitude of second vector, cos of angle between first and second vector. So if somebody tells you that force is acting in this direction, object is moving in this direction, and this is the angle which it makes with force. This is the object which is being pulled by force F but is moving in this direction. Then power delivered by the force is F dot V, which is Fv cos theta. Note down this much. This power which you see has a special name. वो special name आपको यहाँ से मालूम पड़ेगा. V has a technical name. When you write V as ds by dt, what is the technical name for V? We had something before V. What is that term which we had before V? When we write V as ds by dt, this gives you a link the way you remember these things. Who will tell me what is the special name for V when you write it as ds by dt? Good. बहुत सही. Instantaneous. This V is what? Instantaneous. Instantaneous velocity at time t. And therefore this power P also has a special name which is instantaneous power. So whenever you define power as F dot V, at a given moment, you found that velocity of the object is V, force acting on it is F. See, force is acting on the object. That will change what? Its velocity. So, at a given time, instant, you found its velocity is 20. Force is acting is 10. At some other time, this V will change because of the force, and therefore P as F dot V has a special name which is called instantaneous power. Instantaneous power means power at time t, small t. Write down like this. Instantaneous power means power at time t. Now, whenever you define instantaneous, you always define average. If you remember, the moment we define instantaneous speed, we also define average speed. When we define instantaneous velocity, we also define average velocity. When we define instantaneous acceleration, we also define average acceleration. Similarly, when I define instantaneous V, I also need to define average power. Write down the formula for the average power. And look at the shape of this power, work, time. This gives you average. Average power is total work divided by total time. This is the average power. Total work divided by total time. We'll take an example to understand the meaning of instantaneous and average. Look, an object of mass m is dropped from height h. Dropped. And finally, it hits the ground surface. So you need to find what? You need to find instantaneous power just before it hits the ground, and average. Instantaneous is defined at a given time instant, and average is defined for a given time interval. You can also write like this. This average power That's how we write represent average from time t1 to t2. So this is a presentation for average between these times t1 and t2. Suppose somebody says find out average power from 3 seconds to 7 seconds. 3 to 7. You will give the time range. Add this information. So note down the question and write down the question. An object of mass n, is dropped from height h. Find out instantaneous power. Just when it is about to hit the ground. And also find out average power for the entire drop. Instantaneous, I'm asking you over here. Average, I'm asking you for the entire drop. Should not take more than 1 minute to answer this question. Question is find out instantaneous power just when it hits the ground, about to hit the ground, and average power for the total drop. From top to bottom, you need to find average power. I'm telling you, it's a very easy question. You know everything about this question from kinematics itself. It's a hint, kinematics. Remember, we used to solve questions like when you drop something from height h, it takes this much time and it is moving with this velocity. This is something which we have done already in kinematics. From kinematics, we know that when an object is dropped from height h, then just when it is about to hit the ground, its velocity is v, which is root over 2gh. So somebody looking at this block just over here, if I ask him to draw the free body diagram, he will say that this mass m, it is moving in this direction under a force of mg, where v is root 2gh. So right at this instant, what is the power? When I write P, instantaneous power, let's write instantaneous. Instantaneous power is what? Force into velocity, root 2gh, into cos of angle between force and velocity. Force, V, दोनों एक ही तरफ है. Answer. This is the first part. Second part, average, total work. अभी तो बच्चों का खेल है भाई. टोटल वर्क कितना होता है? mgh. यहां से यहां तक mg लेकर आया. Work, how do you find work? Force into displacement into cos of 0. mg downwards, h downwards, cos of 0 divided by total time. Time of fall, not always, only if object is dropped, is given by root over 2h by g. Done. That's how you solve these questions. This is average. This is your instantaneous. Put on this. And many of you answered correctly. Those of you who did not answer anything, do you understand both parts? Yes or no? And if you have any confusion, just let me know. Write down next question. Look at the question. A block is attached to a string of force constant 2. K is 2. Mass of the block is 5 kg. And the important thing is, this is the natural length. So we have to stress the block by a distance of, let's say, 10 meters. K is 2 Newton per meter, mass of block is 5 kg, and there is no friction. Let's keep it easy, mu is 0. Somebody pulled this block 10 meters from the natural length and then you released it. Stretch, release. Then what will happen? It will move towards the natural length. इतना समझ में आता होगा. खींचा, छोड़ दिया, तुरंत लौटेगा. The question is, find out instantaneous power when it passes from this natural length position. Write down the question. A block of 5 kg is pulled 10 meters from the natural length as shown in the figure. Find out instantaneous power provided by the spring force when object passes from the natural length. Let's see how active you are. Good. जितनी देर में आंसर चाहिए था उतनी देर में उसने आंसर दिया एक बंदे ने. That's a good thing. If you are active, then you can answer these questions in just 1 second. The only thing is you need to be active. Somebody, after doing questions on spring and all, what they think that we have to use COME, this and that, they develop a kind of a mindset that this question is going to be difficult. No, it's not difficult. If you look at the question says find out power when object is passing from this position. What is this position? Natural length. When object is at the natural length, what is the spring force? 0. So force itself is 0, then what is the power? 0. Object definitely is moving with some velocity, but we are not interested in that. Why? Because power is what? Power is force. But spring force is what? 0. Object definitely has some V. क्या करें उसका? 0 से multiply हो रहा है. This is spring force. कहां पर? यहां पर. And therefore answer is what? 0. ये ऐसे क्वेश्चंस हैं, इसीलिए किसी भी क्वेश्चन को देखकर पहले से ही ये सोच लेना कि पता नहीं क्या होगा. हाँ, कभी भी किसी एग्जामिनेशन में इस अप्रोच के साथ जाते ही नहीं है. क्वेश्चन पढ़ो ठंडे दिमाग से, देखो, and then you will find that the answer is what? 0. Let's see कितना ठंडा दिमाग है आपका. But the second logic is not correct. One of you is saying displacement is 0. No, displacement is not 0. Object has moved from this position to this position. Displacement is not 0. You stressed it and then you release it. The question says find out instantaneous power when it is passing natural length position. This object is moving with V. and which will be the maximum V. When you release it, it gains V. At this point, V is maximum, and then it moves in this direction. Spring will be compressed, V will decrease. So displacement is not zero, power is coming zero because of this. So let's see how active you are. Write down the power, instantaneous power, right when the object is released. Just the moment it is at a distance of 10 meters, what is the instantaneous power? Fast. At the initial moment, what was the power? Again, same person has answered the correct thing. बाकी लोग क्या हो गया भाई? बेहोश हो गए हो? Question says the object is released. So this is the initial moment. This time force is not zero, but object, its instantaneous V is what? Zero. इसलिए यहाँ पर इनिशियल पॉइंट पर अगर आपसे कोई पूछता तो यहाँ का P क्या होता? फोर्स डेफिनेटली है कितना? K multiplied by 8. Sorry, K multiplied by 10. Deformation is 10 multiplied by V. So this was at rest. The moment you release it, it means its velocity is what? 0. So this is coming what? 0. This is something which you can expect in school as well as JEE and NEET. Now let me see how many of you can answer this part. The moment you release it, it moves in this direction. After some time, it has moved a distance of, let's say, 4 meters. It has moved this much, 4. Right over here, what is the power? I'll give you 1 minute time for this, which means answer is not 0 this time. और ये क्लियर भी हो गया. यहाँ से छोड़ा, इसने चलना शुरू किया. जब ये 4 मीटर्स मूव कर गया है, इस जगह पर स्प्रिंग फोर्स कितनी पावर दे रहा है? You've got 1 minute time. Let's see if you can answer this. Okay, let's solve this thing step by step. First, everybody write down the force which is acting on the block when it is over here. Write down force in the comment box. Write down the force. You have the value of K. 10, 4. What is the force? एक ही आदमी आंसर दे रहा है, पता नहीं उसका आंसर सही है या नहीं. बाकी लोग only one answer so far. Only one answer so far. बाकी लोग सो गए हैं क्या? आपसे बोल रहा हूं कितना फोर्स है, आप बोल रहे हो कि नहीं बताएंगे सर. गुस्सा चल रहा है क्या भाई मेरे से? Why don't you answer such a simple question? What is magnitude of spring force? K times deformation from the natural length. K times deformation from the natural length. Write down this. Since only one person has answered this thing, write down the statement. Magnitude of spring force is K times deformation taken from the natural length. Now, why do I say this whole thing? People have a tendency to write F as kx, magnitude, k is 2, and then they think that body has moved 4 meters. And they go for 2 into 4, producing a force of 8, which is not correct. Everybody will write like this and make a cross. Why this is wrong? Because I told you that what is x? Deformation taken from the natural length. So this was displaced 10 meters, it comes back 4. So how much is the displacement right here? The displacement is only 10 minus 4, which is 6. And therefore this is 2 into 6, 12. That's the magnitude of force. Take across, this is the correct part. क्या याद रखना है? K times deformation कहां से काउंट होना चाहिए? नेचुरल लेंथ से. अब अपने को भाई फोर्स मिल गया, फाइंड करना है V. We need to find V. What is the approach one should use for finding V? Who can tell me? I need V. What is the approach which I can use if I want the value of V? Can you name that approach? Can you write down the approach? सर ऐसे ऐसे कर दीजिए निकल आएगा. Good, बहुत सही. The approach has a name, and that name is what? COME. And why can I use this? Because I don't know कहाँ चला गया, यहाँ कहीं लिखा हुआ था. I had told you that mu was what? 0. There is no friction, there is no dissipating force, there is nothing which is causing a loss of total mechanical energy, and therefore mechanical energy will remain what? Conserved. So if mechanical energy remains conserved, फील करना आसान है. शायद समझ में आ गया होगा. कहीं कोई फ्रिक्शन नहीं दे रखा है, एनर्जी कंजर्व रहेगी. यहां से मैंने इसे यहां तक खींचा, सुनना, यहां तक खींचा, मैं एक्सटर्नल आदमी हूं. अब मैंने छोड़ दिया, जैसे मैंने छोड़ा एक्सटर्नल गायब हो गया. कौन? जिसने खींचा था. दूसरा एक्सटर्नल फ्रिक्शन है ही नहीं. तो यहां से छोड़ने के बाद अब कोई भी एक्सटर्नल वर्क नहीं हो रहा. कौन खींच रही है? स्प्रिंग खींच रही है. बस स्प्रिंग का फोर्स, उसका वर्क नहीं काउंट करेंगे. उसके वर्क की जगह क्या यूज कर लेंगे? पोटेंशियल एनर्जी. स्प्रिंग फोर्स को इंटरनल बनाकर उसके वर्क की जगह पर उसकी एनर्जी को यूज करेंगे, पोटेंशियल. So how do you use COME? Kinetic energy initial plus potential energy initial, kinetic energy final पोटेंशियल एनर्जी फाइनल। यार इसके अंदर वैल्यूज पुट करनी है आपको। इनिशियल कैंडिडेट कितनी है 0, यहां से छोड़ा था हमने, रेस्ट पर था। फाइनल यही तो निकालना है, अपने को v की तलाश है। So if you can write u initial and if you can write u final, then question is done. What is u? It's not mgh. स्प्रिंग फोर्स की बात हो रही है, हाफ के एक्स स्क्वायर, हाफ के 2 x, इनिशियली x कितना है 10, in half kx square, x again is taken from natural length। स्टार्टिंग में आपका x कितना है 10, हाफ के x स्क्वायर, हाफ के x स्क्वायर, फाइनली हाफ के x, फाइनली आप 4 इधर आ गए हो, but this is not the value of x। x is always taken from the natural length which is 6 square। Shift, solve, you will get what v। एक बार v मिल गया तो फिर तो पावर निकल आया ना यार। एक बार v मिल गया तो पावर क्या बनेगा, फोर्स पता है आपको 12, v यहां से कैलकुलेट हो गया है, cos 0 है। क्या है 0? स्प्रिंग कहां खींच रही है, इधर, बॉडी भी कहां आ रही है, इधर। व्हाट इज द एंगल बिटवीन स्प्रिंग फोर्स एंड v? 0। डन। तो अगर थोड़ा सा कैलकुलेशन टाइम बढ़ाना चाहेंगे, this is the third type which you can expect from this। NEET and school level पर, if they frame an objective, well, you can see that you can now answer anything, but the first, second part, say first and second, उनके chances ज़्यादा हैं, but even if they ask you something like this, you can see by using CUME, you can answer the whole thing। If you understand this part, then write down yes in the comment box. And any confusion, write down no and tell me what your confusion is। और इस चैप्टर से डरने की जरूरत नहीं, बहुत ही काम का, बहुत ही इजी है। अभी आपको इजी नहीं लगेगा, अब आपको इजी कब लगेगा, जब आप चीजों को सॉल्व करोगे। So make a habit of solving at least 100 questions of a given chapter। You've got 2 different types of study packages, school level and competitive examination package। So try solving these questions from those packages and you'll find that things are quite easy। Now there is a question, JEE advanced level। ये वगैरह हमारा mostly JEE main। Now JEE advanced, not for everyone। नीट वालों के लिए नहीं है, अगर आप स्कूल लेवल पर सोच रहे हैं आपके लिए भी नहीं है। If you are looking for JEE advanced type of thing, then स्टार्टिंग में पावर क्या थी 0, v0 था। नेचुरल लेंथ पर कितनी थी 0, 40 हो गया था। चीज 0 थी, पावर फिर थोड़ी बढ़ी होगी, इंक्रीज हुई होगी, फिर डिक्रीज हुई होगी, 0 हो गई। वही हुआ है, 0 थी, बीच में कुछ कुछ वैल्यूज आई हैं, एंड देन अल्टीमेटली ओवर हियर इट बिकम्स 0। शायद क्वेश्चन समझ में आ गया होगा JEE एडवांस वालों को। 0 again becoming 0। So what was the maximum value of power from this to this, between these 2 points, what is the maximum value of power? Write down the question. Those who are interested should try this. Find out maximum power in the given question. Find out maximum power in the given question. Note down this much and then you can leave. Thank you very much.